Hello, this is Dr. Marion Carroll, and we're continuing our discussion in organic and biological chemistry, pre-nursing at Dillard University. We're going to begin in Chapter 2, and we will follow on through to the beginning of Chapter 4. And I probably will need another posting for Chapter 4. But in Chapter 2, we begin our discussion of solutions. Obviously, you should know a solution is a combination of a solute, that's usually some type of chemical, or some type of reagent, which is also a type of chemical, plus a solvent. And in many cases, our solvent is water. All right, that will give us a solution. And we can analyze our solution in one of two ways, or we can analyze them in both ways. But initially, we do a qualitative analysis of a solution. And what does that mean? Well, that means we just are looking at the quality of the solution. That could be color. That could be opaqueness, opacity. I think that's a word. So in other words, we're looking at a solution, and we can determine, most solutions, you can determine whether a solution is unsaturated, whether it's saturated, or if it's super saturated. If there's color, then it's easy to tell, because obviously unsaturated would be a lighter color, because these imply the density of the solution that's being made. Also, opaqueness. How opaque a solution is also can indicate its concentration in a qualitative manner. Saturated means it is it has some density because of the solute is in higher concentration than in the unsaturated solution. And of course, supersaturated is let's call it highly dense, because it has more solute than the solvent can contain. Okay, meaning that some of that solute is going to come out of solution, precipitate, not go into solution, because there's more solute than the solvent can dissolve. Well, qualitative analysis is good, but quantitative analysis will give us more information about the solution that we made. And so most of the calculations that we do will be quantitative in nature. How much essentially, is what we want to know. We can do that by percentage. And we know percentage is part over whole. Okay? Percent concentration, percent solute, percent solvent. Also, we can do a molar concentration analysis. Molarity, molar. This has to do with the number of moles of solute in solution. And we'll talk about what a mole is later on. This is necessary to know what the solute molecular weight is. And I gave you a periodic table of elements, and we will be referencing that table when we talk about molarity and molecular weight. What we tend to use a lot of is percentage, percent solution, percent concentration. In our discussion of density, we can actually convert our density into a percent simply by introducing 100 mils of the solution. Okay, we'll be getting a weight volume percent. Okay, for example, if I take 5 grams of sodium chloride and I put that into 100 milliliters of water, okay, I'm going to get a solution that has a density of 0.05 grams per mil. But if I multiply this by 100, what's going to happen? I'm going to get a times 100%. That's going to give me a 5% solution. Because 5 grams in 100, 5 is 5% of 100. And so if I took 5 grams over 100 times 100%, I will get 5%. That's a weight volume percentage. This is my weight, this is my volume. However, if I do the math and calculate the density, it's 0.05 grams per mil. Simply divide 5 by 100. Let's give you an example. A quick example of this. One that I think I used in class. If you have 450 grams, 450 grams of a solution of sodium chloride, all right, 450 grams of the solution of sodium chloride. What is the mass of sodium chloride if I have 35%, if I have a 35% solution? Okay. Now, like the other one, this is, unlike the other one, this is a weight percentage. Okay, because I'm looking for mass in grams, and I'm giving mass in grams. And so I want to know, we know it's a solution, so it's a volume. But we took that volume and weighed it instead of measuring it in terms of milliliters or liters. So how do we calculate the mass of sodium chloride in this mass of solution? Well, it's simple. Our answer is 35%. And how do we get that? We have 450 grams over some mass. Oh, I'm sorry. Let's do it this way. We have some mass, X mass of sodium chloride, over 450 grams of our solution. Okay. Alright, so if we convert our 35%, we know is 35 over 100, which is equivalent to 0.35. So we take 0.35 and we equate it to X grams of sodium chloride. Sorry, it's supposed to be chloride up there. Sodium chloride over 450 grams. We do multiply both sides by 450, and what will that give us? I don't know, where's the calculator? Come prepared. Alright, so we take 35.35 times 450 and we get 157.5 equals X grams of sodium chloride. Okay, remember these cancel each other out. We multiply this, and that is X is equal to 157.5. And so 157.5 grams of sodium chloride make 450 gram solution at 35%. Didn't see that. Okay. There you go. Alright, so I'll move on to electrolytes in the next video. That would be chapter 3 actually. And try to move through that quickly. We'll talk again.